Ladies and gentlemen, we will now commence with the third session of the day.
This session is titled Industry Perspective on Critical Metals, Innovation, Technology and Circularity. It will provide valuable insight into the industrial application, technological integration and circular economy pathways for critical metals.
To preside over this session, we have the honor of welcoming our session chair, Dr. Evan Master. Dr. Master is Chief Scientist and Professor at CSIR SIMFO. He has earned his PhD from IARI, where he was a gold medalist, and has served as a visiting scientist at the Pacific Northwest National Laboratory, USA. His expertise includes the utilization of fly ash, biochar, biomass, and the development of innovative fertilizers, with notable work on slow-release fertilizer from coal washery rejects and mapping rare and critical elements in coal ash. He has received the CSIR Young National Scientist Award, CSIR Raman Fellowship, and National Geoscience Award.
Joining him as the co-chair is Professor Shravan Kumar. Professor Shravan Kumar is an associate professor and former head of the Department of Fuel, Minerals and Metallurgical Engineering at IIT ISM Dhanbad. He is an expert in critical mineral recovery, hydrometallurgy and mineral processing with specialized work in dewatering, float flotation, process control and extraction technique. He has been awarded with the Professor C. Mahadevan Mineral Engineering Science Award in 2017 by the Mineral Engineering Science Association in the recognition of his significant contribution to the field of mineral engineering.
We cordially invite our esteemed chair and co-chair to please come onto the dais and conduct the session. I also invite Professor Shatrughan Soren to come onto the stage as to felicitate our guests. Could we have another round of applause for our chair and co-chair? Now, I would like the chair and co-chair to please conduct the session further.
So, thank you and very good evening to all. Maybe it's last session and the number of participants are diminishing, but I hope we'll have a very interactive session. I have almost 7 or 8 papers, so we'll take 15 minutes maximum, 10 or 12 minutes for the presentation, and we'll take 2 or 3 questions. So I hope all the speakers are present. Okay. Now may I call the first speaker, Dr. Where's the biodata? The first speaker is Dr. Ranjan Paul. Is a Chief Technology Officer at Tata Steel. So Dr. Ranjan Paul is a Chief Technology Officer at Tata Steel with 32 years of experience in steel industry. Previously he led a process and product research. Is having a strong academic background with BTech in ceramic technology from Calcutta University, PhD in metallurgy and material science from Jadavpur University, and MBA from XLRA Jamshedpur. Dr. Paul has expertise focusing on sustainable innovation, particularly hydrogen utilization, carbon capture, high temperature material development and sustainable steel process. He's having many publications with more than 35 patents. So thank you, and with this brief background, may I invite Dr. Paul to deliver his lecture on unlocking India's nickel potential, turning low-grade resource into a strategic advantage.
So, till now you have heard all this hardcore technical lecture. I will do something on the commercial part of it. So this was our objective when we started looking into our nickel ore. Basically, it was overburden of our chromium mines, and we wanted to extract value from it. So first, before going to a research, we search what is happening in the globe. So this is more or less nickel availability. I am not going to that. So we Tata Steel had lot of nickeloferrous material and concentration of nickel into it 0.5 to 1.5. So technically these are feasible material to beneficiate and use. So we started looking how the world is managing it. So if you see high pressure acid leaching is the most popularly used, then pyrometallurgical route for the nickel pig iron, chemical vapor deposition, metal refining, there is few small players in China operating it, one plant at years, and heap leaching. So when we seen all those things that high pressure acid leaching is the main thing driving the business, we have to understand what is happening there. There are two important things. This process operates in the 250 degrees centigrade and with a very high pressure. And enter Indonesia, which is now dominating the world in this. It is basically a marriage between Indonesia and China. China has bought most of the Indonesian company who has the ore and mat manufacturing facility. They are taking the semi-finished material to China, making the battery grade nickel and other things. But only thing is that this plant, if you see the way Indonesia is dumping their effluent, is a big concern. And I'll come to the later where we got stuck up to upgrade our toilet to a bigger facility. So they are just dumping there into the corner of the sea, and till now Indonesian government is allowing it to happen. So that is giving them a very huge advantage of not treating the effluent, because when we made the flow sheet, most of the cost was coming to treating the effluent, recycling it back. So there is a big picture into it. And the next thing is that the economy of scale of those plants. So we have checked that if I buy that technology, put a plant, even if the effluent treatment government allow us to put somewhere, what will be the cost of investment? It will be near about 30,000 crores each plant investment will come to. So huge investment with uncertainty of dumping is creating a problem to the globe. So this is a global scenario. This Indonesian player, how they created a big problem to the big global giant who were that point of time controlling. BHP has closed their nickel business. And many of the Australian players who are in the lead, they are nowhere now. Because this marriage between Indonesia and China, producing the nickel at a cost, it's not possible for a good country with lot of environmental norms to produce nearby places. The same thing for the Glencore, all these people are there. So I am not talk of the hitch leaping, this is one of the process, very people are doing it, more inefficient process, it takes a lot of time. So that was the hydrometallurgy side we are talking of. There are people also doing it in the pyrometallurgy, but use of the hydrometallurgical nickel and pyrometallurgical nickel is entirely different. Hydrometallurgical nickel can produce the best battery grade nickel. Pyrometallurgical nickel mostly produce ferronickel sort of things which is used by the metallurgical industry for stainless steel and other purposes. So blast furnace, RKEF, SAF, these are very standard process. We are also running blast furnace. So we also try to use those routes and see what the economy part of it. It's possible, we are able to make, but economy is this is another interesting process. It is basically a CVMR process for nickel. It's been developed long back. But one of the American company refined the technology, and they have set up plants at China. They are giving the technology rather. Few plants are working on the technology. So what they are doing, they are first taking the ore, they are reduction roasting. So trying to take it in a magnetite ring. Then they are hydrogen reducing slightly. That nickel they are making the nickel carbonyl powder. The nickel carbonyl is basically iron nickel carbonyl system, and then different temperature they are vaporizing and depositing nickel, iron and separating all other material. This is really a very efficient method in the sense, but cost wise there are a lot of questions. So this is also happening, but again it is not only advantage is there, the purity of the material is very high. So only if it needs application they have been there. Otherwise, cost wise, hydrometallurgical route, HPL and other things is equivalent. So when we have looked into all those things, that this is the way world is doing, we also thought that can we do something of our own to develop some other hydrometallurgical route where the high pressure and things may not be needed, and we can do something with a lower temperature. So what basically the challenge is the nickel and iron separation. So what we have tried to do is call it mixed chloride things, magnesium chloride and hydrochloric acid. So both the mixed chloride, we tried to play a lot of way, and we can separate iron and nickel and also a lot of other things. So there are a lot of leaching, a lot of solvent extraction, precipitation. So we developed a flow sheet, and it was giving a good thing that we could recover many things including cobalt and other things. So technologically it was happening. Then we given the flow sheet to Tenova to develop into things so that we can put up a real life plant at our Dhanbad. So after doing so many things, when management was ready to invest up to 1,000 crores, we had to come back. A few things which are things. First thing is that there are few chemicals which are using in the process flow sheet in the later part of the process after nickel and things. So when we were working on that, it took almost 10 years to mature that flow sheet. In that process, some material become too costly and some material, BSF and other, stop manufacturing. So we had to look again some new raw material, again start some experimentation to make this thing. But that was not the real showstopper. The real showstopper was amount of ferric chloride we were generating, and the evaporation was needed for that. And that area we do not have any other plant facility. They will use some waste heat or something to regenerate ferric chloride to HCl and things like that. So if you see, the generation was huge, and that was a showstopper. So to make 1 kilo of nickel, it is 1,000 liters of FCCl3 type of things, and roads and logistics, nothing was there. Efficiency has some use, but it cannot be done in that commercial way. So doing all those things, generating all those, working with the engineering suppliers, we could not ultimately make it happen, because the effluent treatment becomes in this thing. And if you do not regenerate ferric chloride and HCl regenerate back, the question is the economy will not be viable, because getting so much of HCl, that's another costly affair. So we could generate a process. We have large scale, even a small pilot setup. We are very successful. We are very excited. But when we wanted to invest, given this to a technology supplier to design the process and exactly calculate each step what will be the output, we have to stop this project. Another thing is the nickel pig iron. Nickel pig iron is a very simple thing. Nickel and iron both are in the oxide form. You just reduce it in anything. It can be blast furnace, it can be submerged furnace, it can be rotary furnace. Then ultimately what will happen? It will reduce both nickel and iron. Problem with Indian ore is the ratio of nickel and iron is so poor. So we are getting maximum of 2% of nickel. Basically 1% nickel we have, 1 to 1.5. So on the reduction process, maximum concentration can get up to 2 when you can manage the FeO movement something towards the slab. Otherwise the ratio remains the same. And if you have material nickel pig iron, where the iron, this is the normal stainless steel, lowest grade is 2 point nickel and higher grade is 8 to 10 to 16, you can think as that you can think. So there are no user for this 2%, then cost of manufacturing you could not recover. The quantity, the tons of material you have produced still lying in our home. We could not sell. We can sell. We are getting 30,000 to 35,000 rupees a ton of that material, which is nearby the pig iron price. So we could not take it forward. Still we are looking, is there any better way to concentrate increase? So the slag modification and something to take more amount of FeO to the slag so that nickel Fe ratio can be changed. So this is CBMR process. This process also we have tried. The same American company worked with our work. Again, they said yes, 82% nickel recovery with 99%, everything is possible. So only to put a 250 kg demonstration plant, they are looking for 120 crores. So we could not muster the courage, and when you see that what is happening with this type of plant in the globe comparative to the HPL process, we could not create a business sense to investment for this small capacity also. So I will not take this thing. So though there was a lot of promises there, we done a lot of work, but end of the day, the stuck. Still we are looking if something new thought comes in, we like to take it forward. Because with 1%, 5% nickel, there is a business case globally. But only thing is that the way Indonesia handling the market commercially is very difficult to survive as a business. Thank you.
For completing your presentation on time. So we'll take at least 2 or 3 questions. Yes, sir, please.
Microphone.
What is the average grade of nickel in Indonesian deposit? And it seems that Indonesian deposit also contain good quantity of the cobalt and other few more important critical. Is there any possibility what the ore which you have treated, some cobalt and other associated trace elements are there?
Yes, yes, I have shown you in the flow sheet. Can you go back? We had also cobalt. So other flow sheet, we had a plan to take out cobalt as hydrometry. We have cobalt. They have different grades. So they also using this type of lower also in the mix. So they have a 4% of nickel grade, they have lower also. So they are mixing some of this type of lower grade from the market buying also.
See, USA is taking total control of the nickel case made by Indonesia, where good potential of cobalt exists.
But it's not that they are also not taking out. HPL process are also capable of taking out. Go to the next slide, next slide. If you see, this is the, you can see the number, I don't recall exactly percentage wise, but it also giving good amount of cobalt into the system. I am not a hydrometallurgy expert. I will not be able to tell that. Because I am not that.
Actually, we should now companies are there, those who are making in the country itself. So we should encourage our own
I agree.
industry.
Nickel cobalt separation is not that tricky thing. So those we could do, as you said, cyanide, many other this thing, and we started with some of the BSF chemical, changed something, but problem was coming affluent. The quantity affluent getting generated in the process. That was the challenge, not the nickel cobalt separation. Main challenge is nickel iron separation. That mixed chloride technology was giving that, but we are getting stuck into the affluent.
I have not talking about the challenges in cobalt. I know that.
The challenge is there, but we could solve that.
We should also encourage our own industry people, those who are making this solvent in the country, at a relatively cheaper price. And that company like Tata, it gives the.
But problem is we can encourage provided we move forward.
Yeah, yes.
At this point we start. Yes.
The problem with FEL is effluents. Otherwise,
I'll not say problem with you. The way the affluent Indonesia is handling, that is giving them a strategic advantage. But they also know, they also can take out the liquid out, dry stacking of the material. All this technologically they are capable. But to make the process cost lower, they are dumping some of the affluent into the sea. But it's not that 100% affluent, they are also doing dry stacking. So after end of the day, taking out the liquor which is there, trying to recycle something, but many of the things which is not recyclable, they are also doing the thing. So overall they are optimizing the process and more importantly the scale of production. So we are talking with one of the technology suppliers, the minimum viable scale of production, what you suggest?
As you told that Indonesian ore contains 4% minimum and ours
They have
is,
different, so depend on the,
lesser than even 4%.
our is 1.5 maximum
So
solid.
Indonesia, are they treating?
But I am saying is that 1.5% is also acceptable range of things for the HPL process.
Yeah.
Yeah. So thank you. Maybe we can continue the discussion later. So give a big hand to Dr. Paul sir for a nice presentation. Yeah. So let's give a small gift as a token of appreciation from the organizer.
Thank you.
Our next presenter is Dr. Sanjeev Tyagi. He is currently CEO, GMTC Science and Research Center and Advisor Environment, GMTC. He is a fellow of Royal Society of Chemistry, London. He is basically BTech Civil from IT Delhi, MSc Pollution Control, PG Diploma in Environmental Law, his PhD in Environmental Science and also LLB from Gujarat University. He retired as Director, Gujarat Forestry Research Foundation, Gandhinagar, 18 to 22. He was also Director, Gujarat Environment Management Institute, JNE, 2011 to 2018. He was also Member Secretary, Gujarat Pollution Control Board from 2002 to 2009. He was a member of Indian Forest Service 1988 batch, served in various capacities in Gujarat Forest Department. He was instrumental in developing country's first online consent management system to grant online permissions in Pollution Control Board, which received National E-Governance Award in 2008-2009. Under his leadership, JNE has also won the National E-Governance Award for its laboratory management system. He has published more than 30 international papers with more than 2604 citations and has an H index of 14 and I-10 index of 15. He is also author of for management plan of Sul Paneshwar Sanctuary and forest walking plans for Jamnagar division and Rajkot divisions. The book titled Grey to Green on Environment. He was also PhD guide and examiner in environmental engineering. So give a big round of applause to Dr. Tyagi and listen to his presentation. Thank you. And the title of his presentation is Innovation and Technologies in Analysis of Critical Minerals, especially REEs.
Namaste and good evening. Thank you, Chairman sir. The topic is Innovation and Technologies in Analysis of Critical Metals. I have been Chief Executive Officer of this Science and Research Center in GMDC for quite some time now, around 2 years or so. And we are trying to develop a state-of-the-art laboratory. And for the critical metals, including REs. Why this is important? This topic is because I am going to deal with the science, not the technology, which basically concerns the research. the analysis part. So how do REs behave who have very similar properties with each other, not much difference. I call them closer cousins, all 14 of them or all 17 of them, as you can have a look. But there is a catch in that, and as we proceed we will learn what is happening and why extraction, separation is difficult. But I will be concentrating more on the analysis part. Am I audible there? Is it audible? Yes. As I said earlier, I would be focusing on analysis part. So how does it affect how does this periodic table tells us what is happening? We normally forget this table once we leave our schools, but once we revisit, we realize that the lengthenite series the entire series has been put in one cell, and then it has been further extended horizontally, 57 to 71, and 2 at the top. Now they are very similar, how they are. Let's have a look. All of them have very common feature. One is that if you look into SPDF configuration, basically 5D 6s2 or 5D0, 6s2 or 5D1, 5D0, S2, S2. This is what is happening. But the catch is of the F orbitals, which move from 1 to 14. That's a big catch, and that causes the problem. This would sound to be a very simple chemistry, but it isn't. What happens is that as we go down in this list, F increases from 1 to 14. At some places, the F gets repeated because of certain principles, for example, the Aufbau's principle, the other principles, the Pauli's exclusion principle, so many other chemistry principles come into being, and because of that, this series that leads to a concept which is known as lengthenum contraction. And because of that contraction, I think this has come a little early. Now, this lengthenite contraction, what happens is that the F electrons, they prevent the shielding. They are not able to shield the outermost electrons, and because of that, as we proceed downwards, the ionic radii decreases. The ionic radii decreases. From lanthanum to lutetium, the ionic radii decreases. And because of that, what happens is, it becomes very difficult to separate one from the other. And this is the problem that we face when we do hydrometallurgy. This is the problem when we face when we even go for pyrometallurgy or any other chemical method. So this is one of the features that we have to encounter on the way. And this cause of contraction, as I mentioned earlier, is the F series. And SPDF, as you know very well, Schrödinger's gift to the science, world of science. And once it has been proved, it was a hypothesis, but now it has been proved to be true. And we have found that because of that, certain phenomena happen which we were not able to explain earlier, and this is one of those phenomena. Coming back to the previous slide, if we have a look at the REs, normally we say that these REs are found at certain places. They are found more in China, they are found more in some other places. In India they are found in monazite. So other places, even in many parts of US they are found. But when by definition, REs are not, the term is misnomer, and by definition they are supposed to be found throughout the world, even in the continental shelf. And because of that, and because of lack of survey done about them, we always believe that it is found only in China. That was my limited point. We are trying in GSRC to somehow identify, if I have a piece of stone, in that can I identify based on the physical properties of REs as to what exists there, which of the 16 or 17 elements are present there and which are not. So these are some of the points, but I came across a very interesting thing, and those who are interested in physics would know the charge density. Charge density is not very difficult to understand, but then there is another term which is known as corner charge density. Corner charge density, the density is highest here. If an electric flow is there in this table, the maximum density would be here, and if I put my hand here, I'll get a shock immediately. So that is known as corner charge density, and it has been found that the corner charge density of some of the REs is very, very high. So can we use this physical property? Sir, I am presenting a altogether different view about REs, unexplored up till now. We are most of the time talking about chemistry, but can we think in terms of physical property? We are working on that. There are few examples that I have given now, but there are many more to come. And our team at GSRC is working on these aspects. Ionic radii we have already discussed. Once we decided to, in GSRC, once we decided to study what is the reactivity of REs, where do they stand in the reactivity series? In chemistry there is a reactivity series, and it starts from lithium, potassium, calcium, sodium, magnesium, if I remember correctly, pardon me if I go wrong. And I thought, where does RE fit in? And so we worked out, after a lot of search here and there, we came to the conclusion that they must appear above calcium as far as the reactivity series is concerned. And we found, yes, this to be correct, because their behavior is similar to calcium 2+, because their oxidation is 2+, and in some cases 3+ as well, in one of the cases 2, 1, in one of the cases 2, normally 3. And because of these oxidation states, we know how they will behave, and their reactivity is mostly with the oxides. Why there is a challenge in RE analysis? And each time I am harping on the word analysis, because we are restricting ourselves to analysis and not extraction right now. Why does it? Because a lot of interference is there. If you are able to extract the RE also, it might be when you carry out the ICP OES test, or if you have the high resolution ICP also, then also there might be interference by barium oxides. And if you calculate the weight of certain RE elements, and barium oxide would be more or less same, and very difficult to separate. Accurate quantification is not possible because we are not able to digest. Chemically, we also always thought that if we have HNO3, if we have HCl, if we have H2SO4, we can digest any metal. But that's not true about REs. Even the aqua regia, it has been found by the researchers. There is a study done which shows that only 33% of the REs are extracted by aqua regia, not more than that. And if that is so, why is chemistry of RE not important? Because are we not living in a different world by claiming that, oh, we have extracted REs? Should we not revisit what we have been doing? If 33% or maybe 35 or maybe 40% estimation is done, that is an underestimation. And later on we realized that HF is one of the solutions to that. And if we use HF, the extraction may be more, maybe up to 70%, maybe 80% sometimes. And the problem is, which type of vessel will you use then? Because the HF is likely to damage any equipment that you use in long term. How many replacements can you make of those instruments? So that is becoming a little challenge. And this afternoon when I was talking to Mr. Mastron, he told me that they have been working on borates, and we were trying to study borates in GSRC, whether we can use ground borates and carbonates with RE oxides and find out whether the extraction improves. He told me yes, it does it. Thank you so much, sir, for that. Yes. Thank you for correcting again. And this is what happens when we do lot of when we take it forward. This is what happens. One of the solutions for this I found recently in India is high resolution instruments, HR, ICP-MS. We have been using ICP, OES or MS for a long time. But what is the resolution? We have the precision, we have the accuracy, but what about the resolution? Resolution is still poor in all the instruments except this one. We'll see that when we move to the next slide. And optimization of digestion, procedure and analytical instruments, we have to have a good selection of both of them. And let me once again repeat, this I am saying in terms of analysis only. This is we have covered already, I have already said, and HF being coming to our rescue, but not really, because it damages the wall. And there are certain detection methods. Some of the best detection is done by HR, ICP-MS. XRF and AAS also do that, but I will skip this slide and move to the next one. Why? There are two more slides, sir. I'll finish it shortly. If you have a look at this, we have a collaboration with Curtin University, which is the second ranked university in mining in the world. It is in Perth, Australia. We have MOU with them, sir, and we are working with them, trying to find out how best we can arrive at some of the solutions that we are looking for. This is a picture from them. They have shared it with us. And if we see the different technologies here, if we see RBS, XRF, FTIR, XRD, as we move upwards, our detection range is improving and going up to 100%. And starting from nanograms per gram, 10 picograms per gram to 100%. And this is where microgram per gram changes to percentage. You can calculate that. And on the lateral resolution, you find that in nanometers this is 10 to the power 7 and here it is 10 to the power minus 1. So if you want an improved resolution, 10 to the power minus 1 nanometers and compared with 10 to the power 7, as you move in this direction, what happens is that your resolution improves. As you move upwards, the detection range improves. It's an excellent graph which has been drawn by them over a period of time based on what they have done in their laboratory, which is known as D letters. Correct me if I'm wrong. D letters. John D letters. John D letters laboratory at Curtin University, Perth. And when you see there is an unphysical range also, region also, but APT does better, but that's the costly instrument. So if we work here in ICP-MS, this is the range where we can actually achieve the results that we want to. If you have a resolution of 10,000, then you have found a way. It's a miracle, because if you go back to the periodic table, let me go back here. If we go back to the periodic table, what is the difference here? It's got blurred actually. The difference is 0.12, 140.12 to 140.91. So the difference is 0.79. 0.79 atomic mass unit. Whereas HR-ICP-MS can resolve up to 0.235 atomic mass units. And if that is the resolution, you can resolve anything. Maybe this series is very, very similar. Maybe there is a lanthanide contraction here. Maybe they are closer cousins. मैं उनको लेटा हुआ हनुमान बोलता हूँ, लेटे हुए हनुमान. So maybe everything is wrong with them, but if you have a resolution of 0.235, you can resolve anything, and that is where HR-ICP-MS scores. And with that, we can also achieve that. What is that? Barium. 56 plus oxide 64, you can resolve that also here. 64 compared with these values, you can resolve that. Everything gets resolved with HR-ICP-MS. But if you I go to the previous slide, give me 1 more minute, sir. If you go to that slide, if you are going for APT, atomic system, tomography, then you get every solution. So what I am presenting today is that we must look for a best combination of working out a good digestion and technology. After all, it's the technology which takes us forward. So you have to get the best combination of the two, and all these limitations, they get resolved. These are some of the slides which I thought I will present about GSRC. If the time permits, I will definitely do. If no, then I stop here. Thank you so much.
Okay, so thank you, Dr. Tyagi, for this nice presentation. So we can take 1 or 2 questions, quick questions.
You have presented very nicely and explained the behavior of errors, giving the scientific reasoning. One of the slides you have highlighted the importance of ionization potential, the charge density by atomic size, based on that. You explained many things. So my question is that this phosphate minerals, whether it is monazite or genotime. One is rich in lighter errors, another just reverse this heavy errors. In case of heavy errors, I am talking about the monazite and genotime. So monazite contains uranium and thorium in a very higher proportion and lighter errors. Genotime, on the contrary, is rich in the heavy errors and it contains uranium and thorium very less. So based on this explanation we were giving, what is your thought on that?
It's once again, if I can resubmit, it's all due to length and height contraction. And all the properties basically can be explained on the basis of that, because there is an element of F, and in other elements there is up to D. Here we have F range, and half the way this contraction starts happening, and that is how you explain the difference between low and high. Thank you, if I've answered you correctly. Association of uranium and thorium.
You have explained that calcium.
Yes.
Everybody knows that the main rock is the calcium with the like. And the calcium mining radius is very close to other areas. So it is action of substitution. This is a well understood phenomenon. For the uranium and thorium, all these things happen. That's what I just wanted to ask.
I need to study that.
Yeah.
Further. Okay. Thank you.
Okay, so any other question?
Sir, let me inform you that I have a very good team of scientists, all of them very, very young. Sir, for your information, all of them are very young. All of them are less than 35. And they work hard to give me this result. It's not all mine. Yes. Thank you.
Okay, sir. Thank you very much for your overall presentation and interaction. So we would like to present a memento from the CRISP committee side.
So now we move on to the next presentation. The next presentation will be by Sri B. Srinivasa Rao. He is a senior executive, that is GM Exploration at SCCL. He will be presenting on the topic critical minerals, exploration and exploitation for self-sustainable Bharat. So Rao sir, please.
Good evening. Thank you, sir. And thanks IITIS and Dhanbad for giving me this opportunity. So today's my topic, Odyssey into critical minerals exploration and exploitation. Odyssey doesn't mean a dance ballet of Orissa. It is a long, adventurous journey into critical minerals exploration and exploitation. So far, since morning we are hearing about the midstream or downstream activities involved in critical minerals. This is the only presentation I think covers the upstream side.
Okay.
So this is our Godavari Valley coal field in Telangana state, covering 6 districts, and one more district we are going to start the coal mining activity. So everybody knows exploration is a very challenging task on two ways. One is identifying the desired ore is very difficult. So out of world average is, I think, somewhere around for 1,000 people, if they work, only one is getting the ore body in their field area. So out of that one also, so the remote feasibility is economical important block. So first one goes into the only resource, so second one goes into the reserve. So a commercially viable block getting is 10 times more difficult than what we have 1000 to 1. Then rare earth elements, since morning we know very well that they are very critical for clean energy technologies and electronics. The global supply is limited and geopolitically sensitive. Since morning, our policymakers and everybody from VK sir, also sir, Sharon Baum sir and others also dwell upon those things. So I need not tell you why they are critical. The primary sources actually carbonate rocks, so they are very limited in the crustal arena. So the second one comes as a coal waste, that is nothing but overburden material, paste, shales and other things, offers a domestic underutilized source. Actually these things, they are going into the overburden dumps only. So a miner, anyhow he is mining those material and dumping into the overburden dump. So without any extra cost, we can process that material and we can get the valuable REs. So recently, in the month of January only, Secretary Ministry of Mines, he issued a standard operating procedures, how to collect the samples and how to do the analysis and other things. So within this 9 months period, Singareni could be able to collect the number of samples and got them analyzed. So based on those directives from the Ministry of Mines and Ministry of Coals, so our management decided to broaden our operational things. So by way, nothing but we are entering into the other domain. So solar, we are into the coal mining, coal exploration, coal mining, then into the solar power, thermal power, then to solar power, now diversified into the critical mineral exploration and exploitation. So a comprehensive analysis of interesting clays, particularly, then shares. It is a general phenomena that coal is having more rare earth elements, but during our exploration and analysis there, so we noticed that clays and shales associated with coal seams, they are having higher concentrations than coal. Recently, I think 30th September, Utah University also they declared, so the coal associated rocks are having more rare earth elements than coal, and their findings are RE concentrations from 200 to 250 or 300 only. So this is the map of the Godavari Valley coal field. So we have collected samples from one end to another end, so stretching almost more than 300 strike kilometer length. So from every open cast mine we have collected the samples in a systematic way and got them analyzed at different laboratories. Initially, so we entered into this critical minerals analysis and other parts. So the credit we have to give it to IIT, IMMT Bhubaneswar, Dr. Raman Narayan and Kali Sanjay duo. So they encouraged us, they guided us in initial days. Then the second person is NFTDC, Dr. Balasubramanian. So the collected samples were analyzed at different laboratories by paying money for each sample. Not only government laboratories, even to private laboratories also we have sent. The unfortunate thing is different laboratories gave different results. So for anomalies, for one of the set of samples we got the 10x rates. So that is when neobium is 300 or 400, they have given 1400 like that. 140 to 1400. So we got confused whether these values are correct or not. Then we got them analyzed at different sources with the same sample different times. And there we got the consistent values. Then we thought that our place and shades having the RE concentrations of around 400 to 500 ppm. So because so far we have seen the downstream, midstream things, so in the coal exploration, how to collect the samples also more important. So this is showing one of our open cast mines. So you see this red line, this is a fault. So one side is Baraka formation, that is sedimentary terrain, other side is granitic terrain. So we collected the samples even from granitic terrain also. Most of the geological students may be knowing that provenance. So what are the sedimentary terrain got the sediments, got deposited, it was worked out from somewhere else and got deposited in the sedimentary terrain. So the provenance also we want to notice. For that reason we have collected the samples from granitic terrain also. And surprisingly both the values are tallying. So the values are little lower in the granitic terrain because whatever the surface exposures are there, so the RE contents might have leached and went to got deposited in the sedimentary terrain. Slight depletion of the values in the immediate granitic terrain. This is typical view of open cast mine. So you can see the order of seams also from bottom measure to Baraka. Then there is a prominent band, that is bottom measure to Baraka. It is a clay horizon that also containing more REs rather than other minerals seams. At the same time, the first topmost seam 1A1, it contains at least 50 to 100 more ppm than any other place in the downward seams. This is another case. This is from Satpalli area. Here also, that Tumapeta, Talapeta area, there in 1990s itself, GSI workers identified carbonate rocks. So less than a 15 kilometers distance, we opened a Satpalli JVR OC2 mine. In that also we have collected the samples. Here we got the REs more than 450 to 500 range. And this is the closer view of that mines. So unfortunately, in one of our JVR OC1, already mining operations were closed. So in the JVR OC2, it is right now working. Within that mine only we got the collected the samples, and the Satpalli blockery is virgin. This is how we have collected the samples meticulously, and surprisingly, the roof of the seam and the floor of the seam both are containing more RE values, not in between. No coal is having that much value when compared to clays and shales. And these four are elements, particularly cerium, neodymium, scandium, strontium. Praseodymium we have not written here. Then dysprosium and terbium also. These 6 or 7 together, 450 to 500 ppm are available there. This is the closer look. Generally, geologists used to call them as seam structures on 1:50 scale. So meticulously we have collected the samples within the area. For every meter we have collected, wherever the lithological change is there, we have collected the sample. And in those samples only we got these values. So you can see neodymium and praseodymium together 150. Praseodymium has not been written here. And scandium, strontium together more than 100. Dysprosium and terbium more than 30 ppm. So this is a different labs. what are the analysis we got. So then we requested our board to sanction some funds to establish a laboratory on our own so that we can cross-verify each and every sample. Otherwise, we are getting the anomalous data. So we can, by establishing this laboratory, what we are thinking is we can invite the people from academia and research laboratories to check the procedures what we are following, because everybody knows no two intellectuals will come together and work on a single platform. So, being an industry owner, so it will be easy to call upon both the intellectuals to one platform, that is to our laboratory, and we can discuss on the procedures being followed or standards being followed, and we can come to a right analytical data. Then it will be useful for in the further processing work. So the advantages what we are having is, as I told earlier, so industrial waste we are converting into wealth, and there is no mining cost, not negligible, nothing mining cost, because anyhow we are excavating that material. So enrichment of HRE also there, lower radionuclide, so there is no uranium or thorium in that one, unlike carbon dioxide and other rocks where you will have uranium and thorium. If their concentration is slightly higher, then you are not supposed to mine that one. You have to hand over it to atomic mineral division. And as we are using waste, converting it into wealth, it is also environmental benefit. So not only advantages, there are challenges also. RE concentrations are low when compared to primary ores, and simple to complex mineralogy. So how these REs are existing in the lattice, or can it be easily leachable or not? Those things also to be studied carefully. So these are cost effective. Anyhow, this material will be most cost effective than anything else, environmentally friendly, and highly efficient separation and extraction technologies to make these domestic reserves economically viable. So MOUs are JVs by SCCL. So a perfect blend of, generally in Hindu mythology also we used to say Trimurtis. So one academia, that is IIT Hyderabad, then one research laboratory, that is IMMT Bhubaneswar, then a technology development center, NFTDC. So we have MOUs with all these three to guide us in this mission. So the same slide. So this JD12 clay, it is having good enrichments, more than 450. So then we are giving a project to NFTDC. Here we have to say one thing about the NFTDC mindset. So while doing up to this one, this analysis.
So another 2 minutes.
Okay, sir. They are not taken even a single rupee. Generally, people used to ask whether you will give a project or not. By seeing our analytical data and other things, they came forward and they have taken it a challenging mode. So if we prove the thing, what are the REs, can be extractable or not, then only we will take money. Like that they have taken up that project and they have done it. So we have sent them 2 truckloads instead of gram basis. KG based analysis they have conducted and they have proved all those elements are available there. So typically neodymium and praseodymium together 150, scandium and strontium, and dysprosium and terbium and holmium also available there. So this is main. Clays are having around 500 ppm, shales 300 to 400, coal only 250 to 300. So sample wise also we have done. So combination, so grinding, this is the main thing. Only up to 50 micrometer only these REs are easily identifiable. So that means you have to use the 270 mesh size. Then physical verification, hydrophobic and hydrophilic. This activity, it has given 10x enrichment in the RE concentrations. Then leaching also, they have done with only organic acids, tartaric acid, acetic acid, lactic acid, and finally oxalic acid. So oxalic acid has given more enrichment of HREs. That is the advantage we are having. So after leaching all those things, so the material is having only 0.3% of sulfur, 1.83% of iron. That is nothing but iron oxide is 2.6. Only these two in the yellow, if we remove, even without extracting any RE also, by adding some alumina to it, it will give a high value refractory material. So in that way also, this project is very economically viable. So like this, so we can bridge the gap between the diverse professional domains, poses a formidable challenge nonetheless. So we can bring some harmony in that one. So by harnessing the collective expertise and insights of our collaborative efforts, we aim to craft a comprehensive solution that effectively bridges the existing knowledge gaps. Finally, by adopting this approach, so yesterday evening also, Saraswat sir has asked that, do you know TRLs? And we are dreaming about TRL 3 or 4, not more than that. So we are going for TRL 3 to 4 with laboratories and TRL 7 to 9 with the Technology Development Center, that is NFTDC. In this way, we want to convert our waste into wealth, and in the other way, so we are ready to bridge the gap or vacuum created in the RE supply chain. Thank you.
Thank you, Sri Rao sir. Any quick questions? Maybe one quick question.
So what is the cutoff grade of RE in general? TREO, cutoff grade.
Cutoff grade for the economic extraction?
Yes, economic extraction. TREO will be total RE extract when oxide form.
See, in that one also, I have not shown the CDM. CDM is more than 100 ppm. So it is not having any good value. Neodymium, phosphodimium, then scandium and strontium are having some value, then dysprosium and aluminum or terbium. So depends upon the market volatility, it will change. So right now, whatever the elements are available, we are feeling that they are economically extractable. That means up to 500 ppm is enough to extract them economically.
So 500 ppm is quite low, I think. It's okay. Is it so?
That is what I have told in the previous slides also. So unlike primary ore, the RE concentrations are less, but they are more than what internationally they are claiming. If you refer any 30th September English papers from USA, so they have published with a big banner heading that Utah University geologists, they found that RE concentrations in place and other material, and that too the concentration is around 250 to 300. So that they are claimed in a big way, whereas here it is 400 to 500. That's why it is more than that value.
So what will the?
Yeah, I think we can continue that T section, sir. Okay, please.
Sir, you have used many organic acids. Number of organic acids have tested to reach their errors from the source, whatever source you are highlighting. This organic acid, I think it will form the precipitate with rare earths, and it's also hazardous. So why don't you try this dielectric solvents, ionic solvents, like the dielectric solvents is also now an emerging exhibit can be tested.
Sure, sir. That for that purpose only I came here, so we can take the inputs from you people,
Yes,
and we can, the same thing we can discuss with them, other people also. Then we can do the testing with those things also. So these are organic acids, environmental friendly. That's why we selected all these.
No, electric acid is not inorganic. That's what I was telling. That organic
Sure,
ions,
sir.
yeah.
But finally, lichens are concentrates. So what we are thinking is, so 50% is this RE is only 50% is dissolved the other contaminations.
But there are many.
So that means if you take 10 tons, if you got 20 or 30 kgs of concentrates, 15 kg you can extract straight away. So it is a big number.
So thank you. Give a big hand to Rao sir. A small gift as a token of appreciation.
So our next presentation is by Sri Ajit Singh Chaudhary. He is MD of Elitech Earth Sciences Private Limited. Hello, he is basically a mineral engineer with more than 20 years of experience in industry, in R&D, and for more than last 10 years he is running his startup, that is Elitech. Today he will present on a topic unlocking the future of critical minerals, characterization, bridging technology and human capital. So let us welcome Ajit Singh Chaudhary.
Thank you, Shravan. Good evening, Master Sir. Thanks for giving me this opportunity. First of all, I would like to seek blessings from my gurus, Professor Nikam Suresh. He was my dissertation guide. And then my extracurricular guide who helped me in building my career is Professor Subhantro Bhattacharya, sir. Thank you for being here, sir. Apart from that, as Shravan mentioned, I have launched my own company, Elitech Earth Science Private Limited, in 2018, and it has grown with good success with the support from IREL and BARC, supported by Singh sir, Teja Singh sir, Avasti sir, Anupam Mishra sir. So all has given us good guidance in building the know-how across rare earth minerals, and with that help we have set up 7 plants for IREL in Bhopal. So with that, I'm bringing this paper on unlocking the future for critical minerals, characterization, bridging technology and human capital. This paper is majorly for the team who is sitting at the back end of this hall, not for the front rows, because you all know pretty much more than me at least. So this is a paper for you guys, and I would request if you can have any questions at the end of this presentation. Giving you a brief on to Elitech first. Didn't change. In these last 7 years, we have delivered more than 16 projects so far and served more than 50 clients. A few of the clients are mentioned here. The biggest project what we did so far is for IREL. Second one is on the go, which is for Government of Nauru. It's Republic of Nauru, wherein we are doing the turnaround project on a critical mineral called rock phosphate. wherein we are planning to increase their production from 15,000 tons per month to 50,000 tons per month. In totality, we have added a significant top line to our customers, which is more than 1 lakh crores into their top line. In totality, we have more than 300 plus years of experience cumulatively. Also, this company came up with a new concept, which is majorly for the integrated service solution. I'll come on to that as well, and is a Government of India recognized startup. These are few of the photographs which brings our success on paper. On the left hand side, it is the picture of all the plants which we have set up at RETTP Bhopal, wherein these projects are capable to extract lanthanum metal, cerium metal, LED phosphor, lamp phosphor, recycling of rare earths, which Dr. Karthikeyan has mentioned in his presentation, from hard disk drives, then titanium sponge and neodymium metal manufacturing. And onto the right hand side, it's more onto the mining side of it. So with this, we are demonstrating the total value chain. The problem in the current industry is all the verticals in complete mining value chain are working independently. If it is survey or geology, it has got separate profit center. You have mining, which has got separate profit center. Then you have compliances. They are also acting as a separate profit center. Then going on to the engineering and operation maintenance of the assets. What we are trying to bring in is the integrated solution under one roof, and we are ready to take the accountability of every vertical. If one vertical goes wrong, then its impact is significant at the end of the cycle. With this approach, we have already demonstrated a reduction into the implementation time, which is almost 10%, which is significant one, and also reduction in the capex of the total investment. Coming on to the presentation, it covers three major sections, which is on to the characterization of the raw material, going on to the technology, and further down on to the skill set. So on these one, first coming on to the characterization, these are essential things. These critical minerals, they play a vital role. So far we have already seen the kind of criticality it has across industry. Therefore, the essentiality, we all understand why these are important. Major areas of interest are onto electrical electronics, your EVs, telecommunication, etc. Vulnerability of its supply chain, which is it is concentrated onto limited geography. Also, it brings into the geopolitical instability concerns, which can always have the dynamic criticality, disruption into the supply. So, if anything goes wrong, it has got a huge impact onto the complete value chain. Then the global scenario, it's also like most of the presenters have shown this part, wherein I'll give you a brief. Again, the China plays a critical role here, and it can control, like we have seen last, I think 3 or 4 years back, there was a economic breakdown in Australia, which was majorly because of rare earths, because Australia said no to high-grade coal supply to China, and in turn China stopped the supply of rare earths. So in a way, today is a scenario where China can control the economy of different countries. Therefore, to challenge that or to safeguard our own national interest, these entire things are happening across India, wherein we are focusing more onto the critical minerals. In terms of the growth across mineral, we are expecting 3x growth by 2040 in minerals, out of which from clean energy and technology aspect will grow 4x by 2040. The total demand of this covers like majorly from copper and rare earths, which is more than 40% of its pie, and balance one coming from lithium, nickel, cobalt. These are also covered by the previous one. Going on to the next. In totality, we have about 17 elements on rare earths, which has got diversified usage. These are not rare, but then their concentration is limited onto the earth crust, and their economical extraction is a challenge, and that is why these are called rare earths. Your heavy metals, it's more onto the theoretical side. What are all heavy metals and its economic value? The usage of different critical minerals, which is lithium, cobalt, nickel, works on two different segments: energy and batteries, electronic and high-tech sector, defense, aerospace, other industrial and medical applications. And if you see in this, almost in every sector of critical minerals, majority of the area is covered by China. Out of global share, 86% is covered by China, except in one commodity, which is nickel, where Indonesia is playing a major role. This is the global distribution of the rare earths. In previous session also we have seen like the concentration of rare earth varies from down to around 1%, even below 1%, to go as high as 14% across the globe. India per se is not having a good concentration, but then extraction with the development into the technology side, yes, we are still working on to extraction of rare earths. For our country, these are the 30 metals which has been brought under the critical mineral mission, and out of which like GSI has taken up projects on to exploration, and in this current financial year we are expecting about 30 projects taken up by GSI. India has significant geological potential, but because of the limited investment onto exploration side, but this is getting addressed. Private players are getting involved into exploration field. Government is giving exploration license to the private players and offering and giving them the first right of refusal. But still, we are facing issues onto the scaling up of the technology. In present scenario, specifically onto rare earths, we are currently limited only up to production of rare earth oxides. Going on to the metal and further alloy formation is not available in the country. So still we are way behind China, and we need to work on to this area. So if you see the kind of volumes we need to handle to extract a sufficient quantity for the country. I'll give you an example onto the copper here. We need to take out at least 115 tons of copper ore with a current level of operation which is 1%, 0.9 to 1% is the input grade which Hindustan Copper is operating. After treating 115 tons, we are producing 1 ton of metal of industrial application.
Maybe another 2 to 3 minutes, please.
Sure. Then coming on to the technology side, already ISM is working significantly onto the geology aspect of this rare earth area. For processing side, already ISM has been recognized as one of the center of excellence under critical mineral mission. Therefore, we need to work more detail onto these areas. Then for different commodities, different metallurgical routes are being adopted, which are currently in the country at R&D level. However, further scaling up is needed, and for which either government or private sector has to come up for this kind of investment. Giving you a brief onto the process flow sheets. One is onto the lithium processing, the other one is onto the beach sand. And it covers almost every unit operation of mineral beneficiation. Then the major concern which is onto the human resource, human capital, because India has delayed the initiatives onto this segment, so we have very limited know-how. Though at R&D level, yes, we have done good progress. However, at the industry scale, it is still a challenge. We do not have the skilled resources, not only for the projects or the operations, but then when we worked onto the Bhopal project, we faced huge challenge onto the equipment supply. The procurement part was also one of the major challenge because the equipment which are used or which were adopted at the lab scale cannot be replicated into the industry. So to design that kind of equipment was also a major concern. This gives a potential or the motivation to work on to this particular segment. Though the volume of the critical mineral is very low, however, it supports the gross value added industry. Globally, it is about $400 billion, and within the country, it amounts to about $59 billion. So it's a huge value where critical mineral and especially rare earths is supporting the industry. Thank you, sir.
Thank you. Maybe one quick question.
So this beneficiation metal making, the rock types are what rock types you are starting material? Means carbonatite, big sand, or anything you can process and give the final product of lanthanum to.
Sir, we are not an R&D organization, so these flow sheets we have not developed. The process flow sheet comes from the lab, and we give our engineering input onto those process flow sheets. So majorly, like when we have demonstrated onto the copper, it is for the hard rock. Also for the lithium, it was for the brine. Then onto the beach sand, it was on the placer deposit.
No carbonatite for RE?
Sir, as of now, we haven't received any project onto carbonatite kind of deposit. But given the opportunity, yes, we are eager to do so.
Okay, means you do not, flow sheet you collect and then you...
We get the laboratory results. we take the laboratory results which are onto the piece mills on the batch scale. Then we give our process engineering input onto the same and integrate the entire system, and also devise the ways and means how to handle the effluents also.
Give give hand to Ajit Singh. So let's give a token of appreciation. Thank you. Moving on, the next presentation will be made by Sri Rajesh Goyal. He is the founder of Polyprotic Chemicals Limited. His topic is on indigenously developed high performance solvent extractants for critical metal recovery and refining. I'll just read a brief background and CV of Mr. Rajesh Goyal. He is the founder of Polyprotic Chemical Limited and is a R&D lead at manufacturing venture focused on import substitution and achieving India's critical mineral independence. Basically, he is a graduate from IIT Kanpur and City University of New York, USA. He is having more than 20 years of corporate experience in specialty chemical sector, and is an R&D leadership role in multinational industries like Solvay, and expertise in organophosphorus chemistry, metal extraction and other advanced materials. And at Polyprotic, he is developing indigenous solutions for solvent extraction, ion exchange resins and specialty phosphorus derivatives to serve the industries. So Sri Rajesh Goyal sir, please start with the presentation.
Good evening, thank you for the introduction and thank you for the organizers for inviting me here to do this very important event. I cannot move to the next slide. Can you go to the full view board to view the picture? Yes, I think should work. Yes. Okay, great. Okay, so first of all, let me share with you about our company. It's a startup. We started about 2 years ago. And this is a chemical company. The primary purpose of starting this company was to develop chemicals in India, which are mostly imported. So the primary focus was import substitution. And this happened, and we are a core, very hardcore chemical guys. It just happened that we were discussing with lots of these players in the industry across different industries. Metal extraction, mining, recycling was one of the sectors. At the same time, we were also studying agro, farm and all. And we had to, somehow we got connected to the users of metal extraction industry. And they recommended that, perhaps this is the area that we should focus on. And I think I'm very, very glad to, now when I look back 2 years ago or 3 years ago, I feel that it was a very good decision. And a kind of appreciation, kind of motivation, support that we are getting in this domain is very, very admirable. So having said that, so this is what we are doing. We are developing chemicals which are used in the metal extraction line for recycling recovery of these critical minerals. And we are an R&D based organization. So we have a dedicated R&D lab. We are about 10 people in R&D, almost MSc, PhDs in organic chemistry or chemical engineering, and very, very technocrats guys. And then we have you can see here, I hope this one. No, I don't want to go back. I just want to use a pointer. This one? Okay. Alright, so you can see here, we are housed in a government incubator. That's another thing. I came back from the US about 7 years ago or something, and then this entire ecosystem of a startup is somehow, I would say, very, very unique in India. Promotion of startups and all these things are also amazed. I was just randomly looking around and talking to people where could we have set up of this laboratory. And apparently in my neighborhood only, there is an incubator for biotechnology. And I was not aware, even though I was commuting almost every day for 5 years, but I was not aware that there was an incubator which has so wonderful facilities. Almost all high sort of equipment and space and all, everything is there. And I just happened to drop by one day, and then I realized that even this one available, and second thing is it is fully underutilized. So that was second thing now. So immediately I jumped in and we started setting this lab. So this is where in the incubator system we have a dedicated lab. Okay, we are totally we got a blank space and we developed a lab there. And to make it lean and quick to develop product at a commercial scale, we also learned that there are lots of underutilized manufacturing plants, especially in Gujarat. Okay, lots of these guys, they have plants, they purchase the plants during COVID time and all, and they are not able to use them. So now it was a perfect blend. We had technology, we went there, and we started using their facilities, and we could, within a 6 months or 1 year period, we could immediately bring our R&D process developed solutions to commercial scale. And we could even deliver our first order in first year. So this is how it started. And thanks to also our lots of these supports coming from all different government agencies, including ISM Dhanbad, Dr. D.K. Singh, and the team here, but also our other parties. So this is what we're doing. This is our quick model. Now coming to the metal recovery part, I think we have been talking about the importance of critical minerals. I think this I don't have to explain that. Reason being, obviously India is not having a good sourcing of these minerals. At the same time, the market is also favorable. This is an old graph here, which shows the kind of requirement of lithium, which won't be even possible with the kind of mining capabilities across the globe. So the recycling or recovery of lithium from this second source is going to be must to meet the global demand. And at the same time, the process of recovery recycling has secondary advantage, including the waste that would be generated because of spent batteries that could be reused, and mining and recycling. There is a significant difference in the carbon footprint. So now coming to India's ecosystem about minerals and recycling here, I just want to touch upon some quick numbers here, and this is with respect to lithium-ion batteries. So in by 2030 roughly, India would be needing about 160 gigawatt hour of energy of lithium electrical vehicle, which is around 1 million to few millions of electric vehicle cars. And almost 50% or so would that be coming from to their end of life batteries. So, and the what we call that irony is that most of these metals required for lithium-ion batteries we are currently dependent on importing. So import is one thing, the heavy dependency. At the same time, the worst part is this sector. So that's one thing. A second part where we come into picture is the solvent extraction, which I think also my previous fellow speaker they mentioned. Two things I could catch very quickly from their presentation is that first thing from Tata is that there was not ability of solvents at for their scale. Okay, and that's true. And most of these solvents are used in the process of recovery recycling. So the keyword people you might know, Cyanax or PC88 or whatever, most of them are coming from overseas. They are all imported. So they are not available, and that's one of the major challenges. And second is the process of refining. That itself is a very technocratic mechanism. So to develop a process to recover, recycle from these spent batteries itself is a big project, good project. And lots of companies, they don't have the capabilities. So this is something that these two parts where we can play a role. And I want to show you some of the development we have done in this area. So just to give a brief overview of kind of processes that are used in the let's say recycling or refining sector, there are kind of two processes, pyrometallurgy and hydrometallurgy. Iron metallurgy is a conventional method where metals are born at very high temperature and they are differentiated separately. This is it requires very high temperature ovens, energy intensive process. Okay, this is pretty much suitable for large scale ores. Iron metallurgy, on the other hand, it is a much more eco-friendly process. It is a water-based process, and this is where there is no need to have high temperatures. Okay, and it's also suitable for the lower grade ores. And what is even important, what is even more powerful is that the solvent or reagent used in the process, they are all recyclable. So all the solvents we talk about, Cyanex and all that, they are used and they are regenerated and reused and used at almost hundreds of cycles. If you handle them properly, they can be used several times. So that way, these chemicals, the process very, very eco-friendly and sustainable. And this is just a quick schematic of how it is done in the battery recycling. So typically, like I mentioned, spent batteries, there's some mechanical treatment. The batteries, they get black mass, which is a mixture of graphite and metals like cobalt, nickel, lithium and all. And then there is leaching process. Okay, in the leaching process, the metals are converted into their soluble salts such as metal sulfates. Then there is solvent extraction process, which I was just referring to, that is used to selectively separate lithium, nickel, cobalt, manganese, whatever from this mixture. And this is where the role of solvent comes into picture. And not only is the recovery that's important, but also the purity, which is something that has to be there. And normally for battery grade or even for many applications, 99+% of purity is not required. So I just want to tell you here quickly what we have done in last 2.5 years or so. We have developed some of these solvents that you probably in the crowd are aware of by some brands. Okay, unfortunately, people don't even realize that Cyanex is a brand. It's like Maruti. It's not a chemical name, but people don't even know the chemical name. So now we are trying to we are developing these chemicals. We would like you to be our ambassadors and tell the public that Cyanex is a replacement for that. Cyanex is not a chemical; it's a brand. It is a phosphoric acid. Okay, and we have developed equivalent grade for Cyanex. So this for we have developed it equivalent grade, equivalent purity level, and it's already commercialized. Okay, similarly, and this is good for very good product for cobalt value. If you want a separation of cobalt and nickel, high separation factor, it is a beautiful product. Cyanex or our product, the way, but it's a technology that is used for selective separation of cobalt from nickel. Same way, the second product available in the market, IronQuest 290. It has a little bit higher priority than Cyanex 272. That also we have developed and we have filed a patent. We got a process which is even better than the existing production line. Similarly, DEFA is a product very commonly used even in rare earth extraction. I believe people use that. PC88 equivalent, trimethyl phosphate. Even nowadays we are working on anion resin. All of these different solvents commonly used in the recovery recycling process of any sort of feed. It could be battery feed, it could be rare earth feed, it could be any sort of catalyst feed, whatever. Ultimately, these are very commonly used solvents which are used. The process could be different, but the solvent are typically same. So I just want to touch upon
5 minutes.
Yeah, thank you very much. So I will just be quick here, and I just want to touch upon some basic principle of how do we achieve, because there's going to be a question about even the user come to us, okay, can we get 99.99% purity using your chemical? I tell them, no, it's not a chemical alone that does the job. Okay, recovery and purity, two things are achievable for sure, but chemical is there to guide. It's one of the piece of the puzzle. The second piece of the puzzle is the process. The process has to be optimal to obtain the desirable yield or purity. I want to just tell you here, we have done it for battery waste. Okay, so what we have done here on this side here, we developed a synthetic feed, which is a mixture of manganese, cobalt, nickel. Okay, that is kind of the element that you can expect in a battery black mass. Lithium we have also omitted here for simplification, and we have used solvent DEFA. Okay, what DEFA does, DEFA will selectively load manganese. That's what it likes manganese more than cobalt and nickel. So what you can see here, typically in a solvent extraction process, there is a aqueous phase, there is a organic phase, and the metal will be going towards the organic phase because of the solvent. So here you can see the manganese, most of it is going towards the DEFA phase, and the cobalt and nickel, they are more moving towards the aqueous phase. Now, even now, people will say, still I have 4,000 ppm of cobalt and this 2,000 ppm of nickel. It's normal, it's perfectly normal. It's not because of the product. Product is doing the job. Now, this is where the process comes into picture. The process is that you start with this first purified phase and do a further purification, which means now what we do is a scrubbing. So first thing extraction, scrubbing. When we do a scrubbing with a manganese rich phase, you can get a manganese of almost 99.9% purity. Now almost entire cobalt is gone, nickel is gone. So this part of developing obtaining a particular purity metal, it is doable, but it requires a proper process. In some cases, the number of stages, number of treatment, they have to be probably 4, 5, 10, 100 times. In rare earth elements, the number could be even up to 100. So same thing, I know I'm going to be quick here. Same demonstration is here for cobalt nickel separation. Okay, this is where we use phosphoric acid, which is equivalent to Sinex 272 product. We do get the same sort of thing. Cobalt is a majority of the product metal that is extracted, but little bit of nickel also comes along. And to remove that nickel, then we do a scrubbing stage, and we can get high purity cobalt. One more product, Metallurgical Ultra, which is our latest innovation. This is even better. It gets a very small amount of nickel along with cobalt. So that was a quick summary of the solvent that we have developed. Same thing, I wanted to quickly mention that we are also currently working on some of the specialized reagents. And these reagents are more suitable for low loading ores such as rare earth extraction. So this is, let's not go too much into the details about the numbers. What we have done is we got some samples from JNR-DDC. Thanks to Dr. Upen Singh, we did some leaching experiment and we used a reagent, R&D based example, not a fully commercialized solution. But if you can see here, what we saw that we were able to get, it's not working. But here, the good thing is in the two phases, definite stripping, scandium is going towards stripping phase and yttrium is going to the refinite phase. So the separation factor between scandium and yttrium is very, very high. So this is the kind of work we are doing here. Just wanted to touch upon that. And some of the project we are currently working on. We are working on a demo center because again question keep coming to us, okay, can we do this and that? So we are developing a demo center in our laboratory in Vadodara, Gujarat, where we would be taking some of the feed from the users and we can give them high purity samples for the trials. We want to also acknowledge the support from Ministry of Mines, where we got a grant this year, which is recently also got nominated for a award in the startup category from Green Chemistry Award. And that's all. Thank you very much. I would be happy to take any questions you have.
We can have one question.
That solvent you are doing, what you are using, means the starting material is some powder, some metal that powdering that you dissolving them, then you are trying to extract or.
So the process is, by the way, we are chemical manufacturers. So solvent is we develop. Our core focus is solvent.
No, I understand that. But the starting material, in your case, I think we use the batteries.
It is a synthetic feed.
You use the batteries now.
Yes.
Batteries.
But we made a synthetic feed.
But in nature, you get rock types or minerals type of material, which will be a solid material.
Yes.
So in that also, there also you can get all these rare earth element. You can get nickel, cobalt, everything will be there.
Right.
Suppose somebody gives you the powder of those, can you then again process it and?
So this is the kind of things now basically starting from a powder and leaching it out, getting the optimal efficiency of recovery. That's a service project. So that requires a different resources. But once we do the leaching and get the leach liquor which got certain composition, then recovering the metal from that mixture is what our solvent does. So we can do what we have done here is we don't want to focus on leaching part. We simply made a synthetic feed of, let's say, a typical synthetic feed that represent a battery composition.
Suppose somebody gives you a solution, because we are also during analysis, during analysis we are dissolving lot of samples.
Yes.
We give the sample solutions. There are all the metals, all these elements will be there.
Yes.
Maybe high concentration, we will give you, we also give the data.
Yes. Yes.
Can you again from there start?
Yes, so this is where we can, I mean, the process is one thing, but we know that how to get cobalt out, how to get manganese out, how to get zinc out, how to get copper out, okay, how to get,
but in this case, structural metal is a pure metal, or suppose if it is a rock, there will be matrix and there will be matrix effect also. It will have a high value of suppose silica, high value calcium, high value. Then they are the material of this.
They have to be a pre-treatment.
From there you have to separate the bulk amount will be.
So typically a pre-treatment is done.
Yes, there, but the means if you have
So,
such a material,
yeah,
when it is mixed with many other chemicals which you have to throw them, and from there you have to select this the required material. How far your techniques will be successful there? What you are doing is correct.
So if you are right about it, you know, co-extraction is a very common problem, what you are trying to mention there. So typically those co-extracting metals have to be removed first. Okay, manganese has to be removed first before separating cobalt from nickel. Otherwise, cobalt and manganese will come together. So there has to be some pre-treatment that people usually do to remove such kind of special impurity you mentioned.
Yeah, thank you. There's a quick question from a student, please.
Sir, my question is regarding reuse of chemicals. So, sir, what is the processing cost in reusing compared to the original cost, or is it from only your side that the reusable chemicals are made, or this technology is existing in the foreign, in the outside also, out of India also, like out of your company?
So, okay, I think you asked multiple questions. So let me ask you to answer the first question. Is the chemical reusable? Yes, it is. So these chemicals, what they do? It's like, you know, they are ligands. They will bind metal, okay, and after they bind it, it will take to a particular phase, and that phase they can release it again. So the metal goes separately and chemicals stays separately. So this is basically works in the it's a solvent extraction process. If you know the what's the background. So basically the oil phase and a aqueous phase. So they will keep mixing and you can keep getting it back. So that is fully recyclable. Now second question, I am not fully clear if I understood it well, whether we are the somebody using it abroad or somebody they are
the reusable chemicals you have developed indigenously, or it is available outside also?
This is available outside as well, but we have a process patent. So we made the same product but with a high purity. Yeah, or in some cases it is as good as the available technology.
Sir, what is the efficiency better in your chemicals?
They are as good as the current markets.
Okay. Okay, thank you. Thank you. Give a big hand to.
So next presentation is by Miss Mohini from Alpha Level on advanced separation technologies for critical metals, Alpha Level India bridging innovation, sustainability and growing market needs. Ms. Mohini serves as a business development manager, circular separation technologies at Alpha Level. She drives growth in key sustainability areas including mining minerals and battery value chain and renewable chemicals. With over a decade of experience in separation and heat transfer technologies, she partners with industries to implement advanced centrifugation and clean tech solutions for efficiency and resource recovery. At alpha level, she focuses sharply on critical metal recovery, battery recycling, and sustainable process innovation. Mohini plays a critical role in building collaborations across industry and policy stakeholders to support India's green growth vision and national critical mineral mission, positioning separation tech as a cornerstone of sustainable industrial transformation. So over to Ms. Mohini. Yeah, please conclude in 12 minutes. Thank you. Okay.
So thank you so much, sir, for the wonderful introduction. Now, I know it's almost 6:45, but I will try to finish it as early as possible. So, from the phones in our hand to the batteries that drive the green revolution. And we are proud to say that we enable this step with the advanced separation technologies for the critical metals, make the circularity real. So, on the screen there are few numbers about the company performance of alpha level, giving the invoices, order intake and the ROCs. But beyond these numbers, alpha level, we are privileged and unique as an equipment supplier, that we are proud to design, produce and manufacture our 3 core expertise, and we are proud to support and serve all the industries, meeting the 15 out of 17 sustainable development goals and committed to reaching a net zero by 2027 for the scope 1 and 2, and for 50% for the scope 3 by 2030. But beyond these numbers, we have much more in terms of our vision and the behavior. So these are 3 main divisions of the alpha level: food and water, marine and energy. Critical minerals fall under the energy section. So we are pioneering the positive impact. Is the way that it seems it delivers the that's the transformation we feel that we will act, so that our divisions will also grow with their unique mottos mentioned in the bottom. So some key facts about the alpha level. This organization has founded in 1883, which is 140 years old organization, doing the innovation and engineering, operating with 22,000 plus employees all over the globe. The major 3 key technology that we are working on, the heat transfer, separation and fluid handling. Out of that, separation we will discuss in a brief today. And we have 4,200 plus patents with our strong R&D support. So this is the local presence. We have 36 actually major production units. Out of that, 2 is in Pune, Maharashtra. 100 plus service centers. Out of that, 3 is in India. 55 countries with the sales companies. Out of that, 1 in India, and 45 countries with the sales representatives. So we have the strong global presence all over the world. So in alpha level, we focus majorly on clean energy, circularity, water and energy efficiency, with the by increasing the yield using less energy, water and raw materials, that with the help of our equipments, that the core technology, mechanical separation, thermal separation and the heat exchangers. So in circularity, the major focus area is battery value chain, renewable chemicals and recycling. And in the water, you can see that the water reuse, LLD, manufacturing, the drilling and mining and minerals, even the ground engineering. So on the right hand side, these are the existing industries that we make more sustainable. Mining and mineral processing is one of the focus area. And on the left hand side, we enable the transition to the clean energy and circularity. So critical minerals is the focus area. And other industries also falls under the energy division we are focusing on. So when we are discussing the critical metals, the battery value chain will be the part of critical metals value chain. So you can see the complete value chain explained here, right from the mining, the production of precursors or cathode and anode materials, and the recycling. So with the long experience in the mining industry, we help the companies to source and refine the battery materials. Also in the production of cathode and anode materials, and at the last with the alpha level separation and heat transfer equipment, we brings the new life to the critical metals or the battery materials. So now the separation technology, which are the different types that we supply. So mechanical separation, in that you can see the first product is this stack separators. This is a high speed separator machine, which is, it's a pump. So it is used for the product recovery with the high efficiency, for the majorly for the fine particles, which is less than the 0.5 microns, in the process fluid cleaning and for removing the fine particles. The second one is the decanter centrifuge, that is for the water reuse, waste minimization and the product recovery. The first one is a high rotating machine on a vertical axis, for designed for the difficult separations, and the second one is the horizontal centrifugal machine, which is designed for the basically for having the solids form removal. There is a thermal separation also, the evaporation system, which is a ZLD provided with the NBR for the recovery of different solvents, and also to minimize waste minimization. So in case of effluent treatment plant, in the tertiary section, the ZLD comes under for the waste minimization and the water reuse and the fresh water generation. So this is the discharge separators, which I explained you earlier. It is almost, when the alpha level has started with the discharge separator as a milk separator. It's the first product, which is designed 140 years earlier. So this is used for the solid liquid separation, solid liquid liquid separation. So 2-phase and 3-phase separation also possible with this equipment. And this is a compact design basically. You can see the unit, which is of 1.5 meter width and 2.5 meter of length, can take care of the flow of 10 meter cube per hour. And this is completely an automated system provided with the panel and HMI. So there is no manual intervention is required. Only with the help of centrifugal force, we can separate the fine particles less than 0.5 mm up to 0.5 micron. This is used as a polishing step also after the decanter. If when we recover the water with some fine solids, on that fine solids also we can place the discharge separators to recover the more materials. So increasing the yield of the solids or minerals. It's an animation about how the discharge separator works. Okay. It's working, or let it be. So the next equipment is, that's fine. The next equipment is the solid bowl decanter. So you can see it is a horizontal unit and there will be a bowl and conveyor inside. So the feed this is used for the majorly also solid liquid separation, solid liquid separation. So in terms of where the oil solid particles and another water phase will be there, so it will separate water, oil and solid particles as well. So this is also a compact unit for the 10 meter cube per hour of flow. the machine dimensions will be 5 meter by 1 meter and 1.5 meter will be the height. This is also a completely automated unit, and this suitable for the particle size above 5 micron. So till 5 micron, this stack separators, above 5 micron to major size, this solid bowl centrifuge is used. And suitable for the feed solid content 2 to 3% also. This animation. Okay. So you can see there will be a 2 motors for the bowl and conveyor. So feed will enter in the feed zone. This is a feed tube. So feed will enter till the feed zone. The bowl and conveyor already rotating at a high speed, but with the differential speed. Because of the high centrifugal force, the solids will get separated from the one side and the clear liquid from the other side. There will be a gearbox to maintain the speed difference, and no filter media is used. So its conveyor and bowl metallurgy is selected as per the application. So for the abrasive applications like in the mining and minerals, this is the conveyors will be completely there will be a flights of tungsten, which is the hardest material below diamond. So that will take care of the abrasivity of the application. And the solid bowl is also having the different kinds of ribs to take care of the abrasivity. So you can see the dry form of solids will be taken from one side and the clear liquid from the other side. This is all the safety interlocks, vibrations are provided with the machine. This is also a skid mounted unit with PLC panel and HMI. No filtration, no filter cloths are used here continuously. It is a automated continuous operation. So in the remote locations mainly, these equipments we supply with the remote guidance support. So we can monitor this device from our digital center also.
Another 3 to 4 minutes, please.
And this is for the evaporation. So to concentrate the slurry to get the solid outlet. So the heat exchanger, flash vessel separator and decanter for the solid outlet. This is mainly used for the lithium recovery. And these are some sweet spots in the mining and mineral processing where our different equipments, decanter, HSS in various applications of the mining goes in the processing, in tailing, in refining. So these are, and the list of minerals is here. So let's go through some references that we have the global reference in a complete critical mineral value chain. This is a lithium brine processing reference from the Chile. So in the PFD we have mentioned the total reference, the positions of the decanter. So 13 centrifuges are working in this plant for the first installation being in 2001, and we have a strong local service setup also. This is copper and molybdenum processing. This is also in Chile. You can see the dry cake at 88%. And here after the thickener we have provided the decanter to take the solid outlet. Now this plant is actually located at Atacama Desert, so which is also 170 kilometers far away. And we are monitoring this unit through our digital center. And this here we actually replace the complete thickener. So thickener is not needed because this here they were having some filtration technology causing the clogging of the operations. So after replacing with the decanters, they have improved the production and the financial performance as well. So this is the solids that get received from the decanter. Now nickel and cobalt processing also for the this is from the iron hydroxide slurry with the low pH operation. So machines metallurgy is suitable for the low pHs also with the TSS recovery less than 500 ppm. And this is in a battery recycling. This is a reference case in Asia where we replace the filter press with the 2 decanters and 5 distack separators to recover the nickel, manganese and cobalt. These are the installation references. Few of the references from the battery value chain where we are having installed the heat exchangers and the decanters. So lithium hydroxide, carbonate, sulfate. This is a lithium recovery. This is completely skid mounted unit that we supplied. Everything is engineered and designed and manufactured in alpha level. So 4 tons per hour of lithium sulfate, which is taken from the decanter. This is one of the large installation in Australia for the mining operation actually. This unit can deliver more than 300 tons per hour of solids. So small footprints, continuous operation and very less manual intervention. This is for the easy mining also, for the minimization of waste, the zero liquid system we provided. These are the different mining and minerals. So we have installed over 200 plus decanters and high-speed separators. Over 30 minerals, the list has mentioned, which includes the critical metals also. So what we believe that as we are hearing the different challenges of critical metals from the morning, so there is a need to have a new solutions which can be developed and commercialized quickly. So we propose here that there should be a interaction, cross-functional interactions and interventions with the industries, R&D institutions and the technology providers, so that we can come up with the solution which will be from an idea to a full-scale plant, so that the process experts from the customer and process experts from the alpha level side can work together and optimize the solution to make it more economical. So we have all the pilots units with us where we can do the pilot trials at the site and install, then do the scale-ups. So we believe at alpha level, we believe that the collaboration and a strong lasting partnership are the key to the tomorrow's sustainable solution that will reshape our economy and the world we share. So I have already explained the values that alpha level brings in a different applications, but to discuss about some non-technical advantages of this partnership is like cut the cost, risk and the development time. So avoid binding capital on the non-functional tests and reach market first and raise investment more quickly. So we also suggest like R&D, ISM and the R&D institutes in the industries. So for the new application development, alpha level is ready to work in a partnership, so that this is not a regular buyer-seller relationship. We want to scale up and we want to scale up on a globally. So this is actually a scan where you can put your queries, if not possible to answer in this forum, and my details are mentioned. So if you anyone want to connect, anyone want to discuss on the technology more, how we can do that, different applications, you can connect me over. So thank you for the thank you audience for listening so patiently.
Thank you. So we can take the questions later, maybe during dinner time we can discuss. Let's go to the next presenter. Before that, Madam, please a token of appreciation from you. So we have two more presentations. So
I now request Dr. Mohit Gupta, Manager, Process Engineering and Testing Services, Aries India Limited, Chennai, and he will be speaking on Aries novel separation technologies for advancing critical mineral processing. So, Dr. Mohit, you have 12 minutes. Yes. Thank you.
Hello, revolutionizing the critical mineral extraction in India. We have talked a lot about the extraction processes, separation processes, purification processes, but I want to deal with the mineral processing side of the critical minerals. So that's why the topic is Aries novel separation technologies for separation for sustainable critical minerals processing. So we have heard a lot from all the dignitaries here about the critical minerals. So I will just go very fast through the starting slides because this is just a recap of what everyone has said. So just to give a brief overview, critical minerals are used in aerospace applications, electrical vehicles, catalyst development, defense applications, and India has a great, very high dependency on other countries, which includes a lot of geopolitically risk, countries with high geopolitical risk score. And that's why there's a need to develop our own supply chain of critical minerals. So we again have discussed about this. I will go into the resources which we have. Like the resources, as the previous speakers have discussed, consist of primary deposits, for example, carbonatites, igneous rocks, pegmatites, etc. But there are some secondary and the alternate resources, which is also an area of interest for us. Majorly because this is of high quantity in India. The only problem is the concentration is very low. If you start extracting rare earths from these low concentration resources, then as has been discussed before, it will lead to a lot of usage of acid or alkalis. It will lead to a lot of environmental problems in the downstream, and also the resources for directly extracting rare earths from these secondary or alternate resources will be very expensive. So just a typical flow sheet for extraction. In most of the cases, in all the resources which we have, we either do mining, we do sorting, we do collection, which leads to the feedstock for the rare earths. These feedstock will then go to the beneficiation or the pre-concentration step, which can then go into the extraction or leaching step, and then the separation and purification can occur. Now, this beneficiation, we have discussed a lot about the extraction and the leaching step, and the separation and the purification step. So I would like to dwell into the beneficiation step. There are 4 different methods which have been discussed: the size and the density separation, magnetic separation, flotation, and electrostatic precipitation or electrostatic separation. So in the starting 3 out of 4 cases are something with which our company Aries have been known globally for. Aries have set benchmarks for flotation, density separation, and also for magnetic separation, which I will be discussing in the next slides. So just to give a brief overview about the company, Aries is a 83 years old company with a net revenue in 2023 of $270 million, which has now increased to around about $300 million with a CAGR of approximately 20%. We started in USA, in Erie, Pennsylvania, where we started with just a magnetic separator, and then we started dealing with more beneficiation technologies and started working on density separation and also on flotation. We currently have more than 1,000 employees across the globe, and we are in 12 different countries, and we have 100 sales offices globally. So I will start with flotation, one of the beneficiation technologies which can be used for critical minerals beneficiation. The Aries provides different kinds of products for that. We have a cross-flow teeter-bed separator which can be used for density, for classification also. We have hydrofloat for coarse particle flotation. We have stack cell, which is for fine particles or an alternative for the conventional mechanical cells of flotation. We have column flotation cells, which can be used for fine particle flotation, and it's particularly of interest in this seminar or in this conference majorly because all the rare earths are present as fine grade, and therefore fine particle flotation can help you in improving the grade of the feedstock going into the extraction processes. We also have a rotary slurry power distributor. This is an interesting equipment majorly because in the case of mineral processing, it's very hard to get a representative sample across or a representative feedstock if you have, let's say, two different lines of mineral processing equipment going on. So the rotary slurry power distributor helps you in ensuring that all the feedstocks are split homogeneously without any deviation in the feed characteristics in either of the lines. Along with, we also have lab and field technical services which might be helpful here because we can test the samples provided by your side, and then we can figure out which technology will be working efficiently for improving the critical minerals extraction. So the flotation in itself is a very complex process. I did my PhD in flotation, so I can say that it consists of more than 30 variables which are changing at a single unit of time, and therefore it leads to some challenges in the recoveries or the efficiencies of this process, which is majorly represented by a elephant curve. In this case, if the particle size is more than 100 or 150 microns, then because of the turbulence in the mechanical cell, the recoveries of these particles drop. When the particle size is less than 10 microns or 20 microns, then these particles are like inertialess, and that's why they are just moving along with the feed or with the fluid itself, and therefore they never see any bubbles to attach with, and therefore the recoveries are low. In the case, just to go back a little, flotation is a process in which you are using air bubbles to pick the hydrophobic particles out. In this case, your you're making your rare earth minerals hydrophobic, and then picking them out from a pool of gangue mineral, and that increases the final grade of the product. So in the case of critical minerals, most of the dignitaries told us that these particles are very finely grained. During my PhD, I also saw that if it's a bastnasite, then the grain size will be less than 5 microns. If the grain size is less than 5 microns, then you have to grind it to at least 50 microns to get at least 70% recoveries. If you grind it to less than 50 microns, then the conventional flotation will not help you out, and therefore we have to find new ways to do fine particle recoveries, and that's what I would like to discuss here today. First of all, I would start with just the density separation or classification based on density and particle sizes. Aries have developed a fluidized bed, which by using the conventional theory of fluidization can help you in segregating the coarse and the fine particles, or the lights and the heavy particles, just by using Stokes' law. So this should be of some interest here, majorly because the densities of rare earth elements or rare earth minerals are very high, and therefore you can concentrate them just by using a density separator, such as a cross flow classifier. The good part about, or the advantages of using cross flow classifier is that it has very high capacity. It is very precise, majorly because it uses a very fundamental equation, which is like it is using Stokes' laws to do the classification, and it is not dependent on the fluctuation in the feed stream, and therefore it can work efficiently even if there are changes in the upstream or in the mine site. Second, so this is something which we provide for density separation. We have tested this density separators for critical minerals other than the rare earths, for example copper, gold, nickel, cobalt, and everywhere this cross flow separators have been performing efficiently around the globe. The second one is a hydrofloat coarse particle flotation. This may be of less interest here, but it will help in reducing the quantities or the amount of energy which is required for grinding the sample. So the good part about the hydrofloat again is that it is based on the same principle as the cross flow. It works on fluidization velocities. Here, let's say we are trying to beneficiate monazite samples. Monazite samples which monazite is generally heavier than silica, and therefore what we do here is that we add air bubbles to the surface of monazite. By adding air bubbles to the surface of monazite, we are reducing the apparent specific gravity of monazite itself. When you reduce the apparent specific gravity, it floats out, and therefore you can reduce the amount, you can concentrate the feed before it goes into the grinding circuit itself. We have tested this technology on copper samples. We have full-scale units installed in South America, in Australia, and it works very nicely. The numbers here are not from the plant scale, from the lab scale or the pilot scale. These are numbers coming out of the large scale units in Australia. As you can see, by just adding a coarse particle flotation for any critical minerals beneficiation, we can improve the recovery by a significant amount. But the important part is that it helps you in improving the sustainability of the mine itself. You can improve the water recovery by 85%. And that will help you in making any mine more sustainable. Other advantages of using hydrofloat is that here it can float even 1% liberated particles, because what is done is that the bubbles are getting generated along with the feed itself, and therefore these bubbles just attach to even 1% exposed particles. And if that happens, then you can easily liberate, easily float those very, very log particles also. The next one is a stack cell, which is an alternative to the mechanical cells which are used globally right now. The thing with stack cell is that the limitation of the mechanical cell currently is that you have a very large vessel, and you are using an agitator or a rotor impeller machine to just provide turbulence to the entire cell. So you are wasting a lot of energy. What stack cell does is that it concentrates that energy in a very small volume, and that helps in improving the bubble particle attachment, and therefore it helps in improving the recoveries of the fine particles. So in the essence, the large cells, large conventional cell can be reduced to a very small conventional cell. For example, a 200 metric cube cell which was used for a copper flotation can be substituted by a 67 metric cube of a stack cell. So you are reducing the size a lot, and you are also improving the recoveries or the extraction efficiencies, because this is targeting just the feed itself, and it's not losing any energy across this cell or the machine. I would also like to discuss about the column flotation. This is the major technology which is used for fine particle flotation, which should be of interest.
Dr. Mohit, 1 more minute, please.
Okay. So in the case of column flotation, we are basically producing. We have different kinds of bubble generation, which can be either slam jets, where we are directly producing nano bubbles, or we can have cap tubes in which we are mixing the feed with the air, and we are using Venturi's phenomena to produce pico and nano bubbles. So these pico bubbles will attach to the very fine particles, and that will help in increasing the efficiencies of flotation, and that will basically improve the beneficiation process. I wanted to say that we also have this rotating slurry powered distributor, again for improving the separation or the splitting of the feed very homogeneously. Finally, I would just go on to the slide very quickly here. We also are a benchmark company in magnetic separation. I think some of the companies such as IRES are using magnetic separators which are driven by EDs. We are in both wet and dry beneficiation. We can do low intensity, medium intensity, and high intensity beneficiation depending on the ores which we have to process, and we have different products for the same. We have products which ranges from anywhere from 1000 Gauss to anywhere to 13,500 Gauss for dry and wet separation. This is the last slide. We also have lab facilities available in Chennai where we can test most of the things which I have just discussed, and we would be glad to do that and see if we can help in improving the benefit, in improving the grade to the downstream, and therefore improving the overall drive towards making critical minerals domestically. Any questions?
Thank you, Dr. Mohit. Give him a big hand. So thank you for the nice presentation. So if any questions is there, you can have it during dinner time. Okay.
So the last presentation of the day is by Sri Vaitheswaran on fly ash beneficiation for high value mineral recovery. He is managing director in MSN Technologies Private Limited and a visionary leader with more than 13 years of experience in mineral processing and precious metal recovery. His technical specialization is providing turnkey solutions for industry including gold ore processing, mineral beneficiation and proprietary extraction of precious metals from tailings. A key focus is waste to wealth technologies, recovering rare earth and other critical metals from sources like red mud and fly ash.
Okay.
He played. Okay, thank you very much.
Okay.
Please start.
Good evening, everyone. Already it's too late. We can go further. We are in the business of yes. So, okay. We are in the business of metal recycling, metal trading and EPC contractor, mineral processing equipments and process development. Tailing beneficiation also we are doing, auto and scrap dealing and technology provider, project management consultancy also we are doing, industrial automation service provider and information technology is that's a different division. In that we are doing BLDC motor development and controllers. We are in the pioneers of waste to wealth industry, leveraging proprietary technology we have. Our innovative technology separation process is designed maximum efficiency and cost saving. In that we have done the fly ash beneficiation in our pilot plant. In that we have recovered titanium oxide, iron oxide in the major materials and other RE materials also as a concentrate we recover. This is the flow chart. We are using this beneficiation process. This is the flow chart. In these two parts are there. One is primary beneficiation In that we are using 3 methods. It's the wet process, dry material to be mixed into a slurry, and it can be used in this flow. First, we are using 3 parts in that. One is gravity separation and magnetic separation and density separation in the primary part. And the secondary part, we are using magnetic separation, and in that we are separating non-conductive and conductive RE minerals separately. Our results are like this. We are in the process of fly ash concentration. RE concentrate enhanced to 10x from the original level to European. All the RE materials enriched to 10x. In our process, we have done the light rare earths also enhanced to 10x value. These other materials also in the 10x, nearly 10x, we can enhance to the concentrate level. That other toxic elements in the results, it reduced to half of it. Major minerals are iron and titanium. We have recovered in percentage level. We can concentrate to that level. This concentrate can be used for the economic, cost effectively, economically used for the solvent extraction process. Next slide. Okay, in the cost benefits, what we have done is we extracted nearly 500 ton. If we install a 0.5 million ton of fly ash beneficiation plant, from that 5 lakh ton of fly ash, we can recover 500 tons of RE concentrates, with includes HRE and LREs. The iron ore, we can recover 25,000 tons from the 5 lakh ton of fly ash. This cost comes around 32 crore. As a result, we have taken a minimum value out of that. It's a cost benefit of 32 crores we can recover from the 5 lakh tons of fly ash. This our findings. This not for you have to give your opinions, and we have to take it forward by the industry. Okay, thank you.
Thank you. So, sir, I have a small discussion. So, which fly ash you use? It's a lignite based or?
Both we treated, one from Vallur and other from NLC.
NLC, okay.
Both
so
mixed and used.
So the iron oxide, it's from Neyveli, I think.
Neyveli.
So your major income, major revenue comes from the iron.
Yes, that's low concentration. We couldn't do the solvent extraction. It will not be a cost-effective method. That's why we can concentrate and upgrade the material, and we can use it for the solvent extraction.
Okay. So this is only up to physical beneficiation?
Yes, only mechanical beneficiation.
Mechanical beneficiation.
Yes,
okay, thank you. Okay. So any other questions?
Yes.
Physical beneficiation.
Okay.
Your concentration of individual rare earths.
Yes.
Then it's increased by 10, factor of 10.
Yes.
So that is a very good achievement. And from that you have not done any leaching or any other?
No, we have not done. We have tested it in the ICPMS and IXR.
And what about silica and other things?
Silica is there. It's we have to.
Silica also it increases or?
No.
Like
Silica,
other metals, it also decreases.
it goes to the tailing.
That is very good.
Yes. Silica will go to the tailing.
And after, can you just give some idea that once it is beneficiated, the rare earth is getting concentrated, a factor of 10. Then after leaching, what will be the physical characteristics of the school flyers, whether it can be used, whether it is used just like, not it is used somewhere,
Yes.
whether filling or
Filling or road.
any other application is there after bearers recovery?
Already we are
recovered
using it for the road filling and the civil purpose.
and then there is
no other use.
and whether the similar methodology can be, whatever the mechanical beneficiaries of whatever.
Yes, we can do that.
It can be done, it can be applied for the
We are supplier of all the mineral processing equipments and all the magnetic separation.
But whether it can be similar methodology or similar equipment can be used for.
Yes, we can do that. Once you give the lab report.
Already using in the NS.
This Mr. Mishra is not here, I think he went. So actually I will get you.
Yes, we can do that.
Actually I will ask him to contact you.
We can do that.
Then you can just offer some suggestion because we are losing some monazite.
Yes, we can do that, sir. We can enrich and we can separate.
We are using for volume reduction because here we are reducing from 1000 kg to 1 kg.
That is good.
In this we have done 1000 kg to 1 kg.
Going with solid extraction, that is economically.
That is very good.
It's 0.1% we have concentrated.
Thank you.
So one more final thought. So what's the recovery percentage? It is enriched. So if you did you work out a mass balance? Any?
Yes. 0.1%. Concentrate. As a concentrate, it's 0.1%.
No. Total. Suppose you have 1 ton of iron. So what's product? How many ton comes? That was
70% we can do.
For rare earths.
Rare earths we have to check. In the leaching process we have to check.
Okay. Okay. Thank you, sir. Thank you.
Thank you, sir. We extend our sincere gratitude to all our speakers for their insightful contributions. We also thank our session chairs for their expert guidance throughout this session.
May I now request Professor Aarti Kumari, convener of CREST 2025, to kindly present mementos to our chair and co-chair as token of our appreciation.
Thank you, ma'am. This concludes the academic proceedings for day 1. We request you all to kindly join us for dinner at GGLT Dome. Thank you, everyone.
Okay, before leaving, I would just like to remind that all of the externally registered members, if they have not collected their trolleys, please do so from the registration section. Thank you.
Onto the dais to upload their presentations in order to have a hassle-free talk. So the speakers being Dr. K. Anand Rao, Shri Anuttam Mishra, Dr. Arvind Kumar Mishra, Dr. Sandeep Ghosh Chaudhary, Shri Mohan Babu Verma. We request you to kindly come to the dais to upload your presentations.